welcome to move forward. What we're going to talk about here today, we'll talk about the anatomy of HP Cloud Foundation for Hyper-V. I'm assuming that most of you are aware of the Hyper-V Cloud Fast Track program, a program that Microsoft has put together to develop a blueprint for private cloud infrastructure running on Hyper-V. And they worked with a number of OEMs to deliver their own fast track blueprints. So what you're seeing here, the HP Cloud Foundation for Hyper-V, is HP's blueprint for a Hyper-V cloud based on the specifications in the Hyper-V Cloud Fast Track program. And it's a little bit different, perhaps, than some of the things that you'll see from other OEMs because there's a strong flavor of HP Blade System Matrix and some of the HP Insight software as part of the mix. So as we go through this presentation, we'll try to give you an education on what is HP Blade System Matrix and what does it bring to the table, how does that interact with System Center to deliver HP Cloud Foundation for Hyper-V. And my name is Brad Kirby. I'm from Houston. I'm in the industry standard server team down there, and my focus is on the Microsoft partnership. So I work with Aaron Holzer in the room here from Microsoft on the Hyper-V team, work with him on a daily basis, and also folks in the System Center organization as well. So in terms of today's agenda, we'll do some introductory slides around HP, Microsoft, and cloud computing, how are we collaborating. We'll also try to set the scene about, cloud can mean so many things. What is it exactly that we're talking about with HP Cloud Foundation for Hyper-V? We'll drill into the solution itself, understanding of Matrix, integration with System Center. And then what we're going to do is we're going to talk about a couple of use cases that we've developed as part of this program. So when you see the HP Cloud Foundation for Hyper-V from HP, and we'll show you a website that you can go to at the end of the presentation, you'll see that we have a use case implementation guide. So in addition to the reference architecture that kind of specifies what is the hardware and software stack that we're talking about, we have a guide that tells how to implement the use cases that we're going to talk about. And then we have MMS here. We also have the same configuration at TechEd. We actually have an HP Cloud Foundation for Hyper-V here. The reason that we have MMS on this slide is we collected a bunch of statistics on how our private cloud powered the entire hands-on lab. So you'll get a sense for how many virtual machines could we host on the infrastructure, how quickly could we power up those VMs, et cetera. Okay? So hopefully the presentation is informative for you. I'll run through. We can handle some questions at the end, and then if you want to come up and talk to me afterwards, we'd be more than happy to hear any questions and answer them for you. Okay, so what's driving the move to the cloud? I think this is fairly clear to everyone. Why are folks moving there, right? Speed, flexibility, economics. When we talk about speed, we're talking about, hey, every time I want to deploy an IT service, I don't want to be having to call the IT department. I want to be able to do this quickly. I'm a line of business administrator. I'm an application owner. I want to be able to get that infrastructure up and running without having to talking to the server admin and the storage admin and the network admin. Flexibility in terms of the way that you use your resources. The resources aren't static. When a resource or a service has been used, those resources can be returned to the pool. And economics, you're making more efficient use of the resources that you have in your environment. And what we're actually seeing is business is adopting the cloud 5x faster than IT operations. What does that mean? Going around the IT department, going to Amazon, going to Google, going to Azure-based cloud services to get applications online. What we want to try to help do with the private cloud is give the IT department more control over that infrastructure and prevent that end around in as many cases as we can. IT challenges that we're looking at here, sprawl, control, and integration. The cloud helps overcome each one of those. And we're also trying to flip this ratio between maintenance and innovation. So 70% of IT resources are captive in maintenance and operations today. What we're trying to enable with cloud computing is, hey, let's focus less on maintenance and operations, focus more on innovation, and cloud and template-based provisioning and many of the things that we'll talk about today enable you to do things in a more repeatable, more automated fashion so you can focus on the next set of developments for the business. In terms of what constitutes cloud computing, I won't spend a lot of time on this slide. There's infrastructure as a service, which is essentially how do I request infrastructure, typically up through the operating system or potentially the virtual machine through some sort of a self-service portal. Platform as a service, oftentimes being able to request a development platform through Azure or a like service. Software as a service, really getting the entire service up through the application, typically through some sort of a public infrastructure. Salesforce.com, obviously, the BPOS or the Office 365 being a great example of software as a service. We're not going to talk about platform as a service or software as a service today. We're going to be primarily focused on infrastructure as a service and how HP and Microsoft contribute to deliver that. And also, there's the notion of public cloud and private cloud. Obviously, public cloud, sourcing those resources from a cloud provider. The enterprise is consuming those, but they're all delivered through a third party. Private cloud, meaning that the consumer and the provider are both captive within the same organization. And today, really what we're going to be talking about is how you deliver that private cloud for your organization. Okay, so what are the key benefits? We talked about reduced cost by being able to do things in a consistent, repeatable way through templates and not having to reach out to the IT organization every time you want to deploy a new service. Agility, being able to get those services up and running faster, and highly automated. Once you've actually designed the template that you're going to deploy, individuals within the organization can instantiate that template multiple times. And then when we talk about core attributes, obviously self-service. You'll see the self-service portal that we deliver through the joint solution here, and scalable and elastic. You can quickly ramp up those resources. And then one of the videos that we'll show here today is how you can flex resources, bringing a server from one resource pool to another resource pool without disrupting IT services. So reduce cost, agility, automation, self-service, line of business and IT application owners can request those services easily. Scalable and elastic, you can grow them and you can transfer resources between pools easily. So, HP Cloud Foundation for Hyper-V, leveraging the best of HP and Microsoft technologies. Again, this is a reference architecture that we've put together as the framework for private cloud. We have a bill of materials that we deliver as part of that reference architecture, so you can build one of these yourselves. We don't deliver it today through Factory Express within HP, but this may be something that we look to do in the future. We'll be talking a lot about this optimize area, how we allow you to design templates, publish those templates through a self-service portal, use that to provision infrastructure, how you automate response to faults within the environment using a combination of HP and Microsoft technology. And the fact that you're using templates that are designed once and implemented many times means you have that higher degree of automation, but you also have a much more reliable service delivery because it's being executed according to that template every time instead of introducing human error into the process. And then finally, jointly validated under the Hyper-V Cloud Fast Track program. So we have had folks from Microsoft who are responsible for the program validate the configuration, and HP Technical Services can deliver this on your behalf. In fact, we have a fairly large number of proof of concepts that are already underway that have been sponsored jointly by HP and Microsoft in the United States, in EMEA, and quite a few in Asia Pacific as well. And the core components of HP Cloud Foundation for Hyper-V are listed here. HP Blade System Matrix. Blade System Matrix is used to design the service templates that you will deploy. It's used as the self-service portal, so the end users who want to provision the service are able to request this. It's able to do the service provisioning, and then it will also do service recovery. Microsoft System Center, used to monitor the hardware, OS, and applications, does all of the lifecycle management of the hardware and virtual machines, can also be used to patch the operating system and applications. We have integrations as well that enable you to deploy firmware and driver updates, and data protection as well. HP Insight Control for System Center is what creates the connection between the HP Blade System Matrix and the System Center environment, making sure that any faults that occur within the hardware are reported into System Center, and allowing System Center and System Center VMM to take automated action based on those faults within the environment. Okay? So as we think too about the solution, let's talk a little bit about what is it that Microsoft brings to the table and what is it that HP brings to the table. We're very excited about what we're seeing with Windows Server 2008 R2 in the virtualization space. Obviously, critical was bringing live moves to the table. We've also seen in the hands-on labs downstairs, which are being powered by this cloud foundation, the dynamic memory is absolutely fantastic. The efficiency that gives you in terms of deploying virtual machines and really using all of the resources as efficiently as possible is unparalleled. And then obviously System Center is a key element of the solution, providing that lifecycle management from the hardware infrastructure up through the applications, really in a way that you're not going to find with other cloud solutions on the market. Many of those, yes, sir? The lab downstairs is based on Blade System and EVA. We don't have all of the Matrix software loaded on there. We did a custom build for the hands-on labs that are down there, but it is the same configuration that you would see as part of a cloud foundation. And you can expect to see the same level of performance from that configuration down on the floor. So definitely come on by and check it out. Okay. Blade System Matrix. Let's talk a little bit about this. Matrix is responsible for creating the resource pools within the environment, obviously creating the pools of servers, storage, and network connectivity. We'll show how that's done as we go through the presentation. Matrix Service Delivery is responsible for provisioning the infrastructure. We're also going to talk about how we've created some PowerShell scripts that can be hooked into a Matrix environment to allow the automated configuration of a failover cluster. Capacity management, the self-service portal, obviously critical. All of the templates that are designed are actually are advertised through this self-service portal so that the end users can request them. And then the service catalog that sits behind that self-service portal. We also have a set of APIs that can allow both our own services and other service organizations to come in and deliver billing and chargeback, approval flows, other things to get that integrated into what the customer may have within their environment. So again, this Blade System Matrix is going to be largely responsible for doing the provisioning of the IT services within the environment. So let's take a look at some of the elements of the solution here. So in terms of designing the infrastructure templates themselves, you can see that, see if I can get the pointer on here, yeah. There's a palette of components here on the left, physical servers, virtual servers, storage components, networking components. You can create your own set of templates, or HP also has what we call cloud maps, which are pre-configured templates for different solutions. So we have cloud maps for Exchange, we have cloud maps for SharePoint, we have cloud maps for Lync and other applications. These templates capture all the requirements that are needed for configuring servers and storage and networking, and we'll show how that's done in a second. There are a set of validation rules that check that template for error, so you're not able to create a template that can't be instantiated within the environment. And then, of course, you can publish those templates out to the self-service portal. And we have a mechanism to add cost information to the templates as well. So when you go about deploying the template or deploying a service, you can associate a cost with each one of those services. And that's one of the key tenets of cloud as well, right? That you're able to quantify everything, and you can quantify the value of the service that you're deploying for chargeback purposes. In terms of the self-service portal, fairly straightforward here. I have a set of services that have been advertised through the self-service portal. I can pick the service that I want to deploy. I click Go to deploy it. And then I can track the progress of that deployment, because it's going to go to the administrator. The administrator needs to approve it. And then I can watch it through its life cycle until it's actually been deployed. The other thing that we can do is we can create lease periods for these services. So one of the things that we find with traditional IT a lot of times is I deploy the resource and it sits there forever, right? It never gets returned to the resource pool. With HP Blade System Matrix, and consequently with HP Cloud Foundation for Hyper-V, once that service has come to the end of its lease life, it can be returned to the pool so that those resources can be used by other applications or other services. Okay? Another important piece of the infrastructure that we're going to show, and it's going to come into play when we talk about flexing later on today, is this notion of a logical server. And what a logical server is a profile that can be associated with either a physical device or a virtual device. And that profile can be moved around in the organization. So when I go to deploy an IT service using HP Cloud Foundation for Hyper-V, what I'm going to do is I'm going to deploy these logical server profiles. And you can almost think of it as thin provisioning of the service. I may say that this service can have as many as 5 logical servers within it, but I may only choose to instantiate 2 or 3 of those, and then I can bring other servers online as necessary over time, which is that scaling element that we talked about earlier. I can also move servers between pools, and because Matrix operates in a boot from SAN environment, moving even a physical server is as easy as saying, I want to associate this logical server profile with another physical server within the environment. That server will then boot up using the profile of that logical server and take on its personality. And we'll show how that works as we go through some of the demonstrations later on in the presentation. Okay? So remember this logical server concept. It's pretty important for the flexing use case. Okay? And we talked a little bit about Insight Control for System Center earlier. Again, this is the glue that brings the Insight software value add in contact with the Microsoft value add. And I want to talk about exactly what we do with each of the different elements. So System Center Configuration Manager. We enable bare metal deployment through Configuration Manager, automated driver and firmware updates through Configuration Manager, and then deep component level inventory through System Center Configuration Manager. In the particular examples that we're using here, we don't use the OSD integration element. That's done through the Matrix provisioning engine. But certainly the update of driver and firmware can be done through Config Manager. And also the inventory of all of the components of the Blade system environment can be done through this mechanism as well. Operations Manager, absolutely key to what we're doing, being able to monitor all of the infrastructure components, seeing all the faults, seeing the Blade system enclosure and the status of all of the components within the enclosure and the servers themselves, and providing access to all of the individual tools that reside within the individual blades, or access to the enclosure manager. That is all accessible from within the System Center environment instead of having to switch to another console. And you can actually see this downstairs on the floor as well. We have in the HP booth a demonstration of the Insight Control for System Center, as well as in the hands-on lab. You can see that operating and managing the environment. And then finally, the Virtual Machine Manager. We have a Pro Pack for Virtual Machine Manager, and we will show that in action as one of the demonstrations later in the presentation. Okay? So, you may be, folks are probably aware of Insight Manager. Folks are probably aware of HP software. Many folks are not aware of the fact that we've invested a considerable amount in driving integration of the Insight software value into the Microsoft System Center environment. So if you're consolidated on System Center, you can get almost all of the same value within System Center in terms of hardware management that you'd be able to get through the native tool set. Okay? All right, so let's talk about the use cases that we're implementing with HP Cloud Foundation for Hyper-V and that you can implement yourselves using the guide that we've created. We're going to demonstrate 3 of these here today. There's IT Services Fabric initialization. This is how do you go through the process of getting your environment to the point where you're able to deploy virtual machines. How do you get all of the hardware configured? How do you deploy the operating system? How do you do automated configuration of the Hyper-V role? How do you do automated configuration of the failover clusters? Flexing IT services. We talked about this a little bit before. I have an OLTP service in this case and a batch service. The OLTP service I have running during the week. I want to have 3 servers in that pool and only 2 in the batch service. But then when the weekend or the end of the quarter comes around, I may want to shift resources between that OLTP pool and the batch pool to do that batch processing at the end of the quarter or the fiscal year. So we'll talk about how we do that in an automated fashion as well. Transparent failure resolution. One of the key things about virtualization in cloud is you're going to have more workloads running on each server. Each one of those servers becomes a mission-critical element within your environment. So you want to ensure if there's a hardware failure that puts that physical asset at risk, that you can automate the migration of the virtual machines to other nodes within the cluster, and then get that in maintenance mode so you can take care of the problem. So we'll show you how that is done. And then network resource rebalancing. We're not going to do an actual demonstration of this, but just so you know, there's a technology within HP Blade system called Flex Fabric. One of the capabilities of Flex Fabric is the ability to partition a 10 gigabit LAN into 4 connections. So there are 2 LANs in each system. You can have up to 8 connections. Not only can you partition them, but you can dial up and dial down the bandwidth in a programmatic fashion. So if you want to have all of that bandwidth allocated to your production network during the daytime, and then you want to tune up the amount of bandwidth allocated to the backup network during the evening, we provide you the capability of doing that without having any disruption to the services that are running on those servers. Okay? So 4 scenarios that we're focused on, and we're going to now dive into the first 3 of those that you see here. We'll walk through the scenario, and then we'll show you a short video that illustrates how all of these pieces come together. Okay, so the first one is IT Services Fabric initialization. So there's going to be a role for the Matrix administrator, and there's going to be a role for the System Center VMM administrator. They're going to define the requirements for setting up the Fabric services. And what we're going to show in the demonstration today is how do we set up the boot disks, so the images that are booting from SAN. How do we set up the clustered shared volumes, your data disk? What are the network configurations going to look like so you can get a sense for the different networks that we want to have in the environment? And then Insight Dynamics is going to be responsible for deploying those logical servers to the physical hosts, enabling the Hyper-V role, and joining the domain. Then what you're going to see is we have a set of PowerShell scripts that we run. In the demonstration, we're going to show each of those individual PowerShell scripts running, but those scripts can be integrated into an Insight Dynamics environment. And then System Center is responsible for deploying the virtual machines within the environment and monitoring that infrastructure. It turns out that you can deploy the virtual machines using Matrix. You can deploy the virtual machines using System Center VMM. It's just your preference and how you want to implement that. These are, again, we're going to have two pools. We talked about an OLTP pool and a batch pool. We'll have three physical servers in each. All of those physical servers will not be instantiated. Only two of the physical servers will be instantiated in the batch pool, and that's how we transfer resource from one to the other. You can see the boot storage here, the shared storage, and the different networks that we plan to put in place. So the first step is going to be to create the resources that support the automated workflows. So just really quickly, obviously you have to rack, cable, and discover the servers. We create the networks in the Blade System chassis that you see here. This is done with Virtual Connect Enterprise Manager for those of you who are familiar with HP Blade System and Blade System Matrix. Just a drill down into the management network, for example. We can configure it so that it's PXE enabled to enable the provisioning of the services. We can configure it to automatically join the domain post the deployment of the operating system. And then we also have the ability to either physically pull IP addresses from a resource pool that we've designated, or have the software automatically assign or get IP addresses, from DHCP. So you have that flexibility. And then you will create the LUNs. The storage administrator will create the LUNs that are used as part of this and create the storage resource pools within HP Blade System Matrix. Now, with versions before 6.3, the storage administrator had to create the LUNs, and the creation of these storage pool entries and the LUNs were separated. Now, as part of 6.3, you have the ability to actually create those LUNs themselves within HP Blade System Matrix. So there's a storage administrator role, and they can create the LUNs. Yes? No, it will support EVA arrays, but it will also support non-HP storage as well. Okay. Sometimes, I'm not sure the exact differences. We do use SMIS to do a lot of that work. So a lot of times it's what is supported by the vendor in terms of SMIS providers. So those that do a good job of supporting SMIS, we do a good job of being able to configure here. Those that don't are a little bit more problematic. Yeah, absolutely. In the QEC spec and the implementation guide, there is a compatibility list. Okay. And then we create the server pools from a list of servers that have been discovered by the Blade System Matrix infrastructure. Okay? We also will create a set of deployment jobs that are used to do the automated deployment of the operating system and configure the hardware so that it can boot from SAN, et cetera. And actually, this is the deployment job details. This is all outlined in the configuration guide, but we've actually created a specific deployment job that will configure the BIOS to boot from SAN, will enable hardware-assisted virtualization. We install the operating system, enable the Hyper-V role, and we also install the ProLine support pack on top of that so it's immediately manageable. And then the final thing that we have here is we actually copy over the PowerShell commandlets that are used for some of the post-deployment configuration. As I mentioned, we're doing that in this instance so you can see the PowerShell commandlets run. Those can also be integrated into the Matrix environment. Okay? And then this gives you a sense for the template that we create. We have a set of server resources, a set of storage resources, and a set of networking resources. And we would go in through and configure each of those items within the template. So our group name is OLTP. We have 3 servers that we've added here We can define the number of processors per server, the memory size for the particular system, what's the processor speed, what is the architecture. And if we had different types of servers, we would create a template for each one of those. When we get to the storage, you'll see we have obviously a different template for the boot volume and for the clustered shared volume. Okay? For the network and server network settings, you can configure them here. Probably the most salient point right here is you can see whether you want to configure them as DHCP or static IP addresses in this case. And then for the storage resources, you can see that we have the configuration details for the boot LUNs on the left and the clustered shared volume on the right. So 40 gigabytes, fiber channel here. The disk, is obviously bootable in this case. Clustered shared volume is, a data disk. In this case, it's not bootable. Both of these are fiber channel for what we've identified here, but we do have an iSCSI add-on to the EVA that we've used as the basis for this initial Cloud Foundation reference architecture so that you can do guest clustering within a Hyper-V environment. Okay? And then we have the OS deployment package. So I check the OS deployment package. And then when I've configured all of those things, I've configured my storage resources, my server resources, all the network resources. Once I see that validation status is green, then I can go ahead and publish those resources. And then they'll be made available through the self-service portal. Okay? Now we're looking at the other side, creating a service from one of these templates. I'm within the self-service portal in this case, and I select a service that I want to deploy. I hit instantiate the service. I can add some information about how I increment the host names as they're deployed. If I have multiple services within the group, I can input other information if I need to. And then it's going to go to town and actually instantiate that service. It's going to hook up all the server, storage, and networking configurations. It's going to deploy the operating system. And then in a second, we'll talk a little bit about how we integrate in the PowerShell scripts. Okay? So let's go ahead and take a look at this. We're going to run through all these steps as part of a quick video. Okay? One of the things that you'll see here, we're actually in the Insight or the Insight orchestration portion of Insight Dynamics. This is kind of the home page, if you will, where you can get an overview of all the resources. I can see my physical servers. I can see my storage. I can see how much memory I have. I can see how many CPUs I have. The DHCP IP addresses, what pool I have available to me. Okay. Sorry. I must have clicked something wrong there. Okay, starting over. Okay. So these are the storage, or sorry, the servers that we have in the pool that have been discovered. We can see the storage LUNs that have been created for this particular environment. These can all be used as part of the service. And we can see all the network connections that have been configured initially during Virtual Connect Enterprise Manager. These are all of the resource elements that will be used as part of deploying the service. Yes?
Quick question. When you designed the template, you were saying you want a single proc, physical server.
Yeah.
What if there's no single proc servers in the pool that you just built?
Yeah. So
we have enough. Maybe there's dual core or whatever, but will it take one of those? Would report back an error?
So what it will do is if there aren't servers that match the template in the environment, then it will say, we don't have any of those servers. So you either modify the template or you have the resources there that you need. The assumption here is that there's some planning in the back end around, what is the actual infrastructure that we need from server storage networking perspective. And then once that's in place and the templates have been designed, knowing what's available, then people can just go ahead and request that. So I think you would want to do some planning to make sure the information that's in the template is actually matching the resources that you have in the environment. Okay. There we go. Okay. So now what we're going to take a look at is actually designing the service. So we're going to bring over a physical server group. And what this will represent here is, come on, here we go. What this will represent, this server group, again, is like types of servers. So if I have a multi-tiered service with, say, BL460s and BL680s, I would have different server groups that I create. Now we're also bringing the storage volumes online. So you can see there's Fiber Channel SAN, 2 of those, and we're going to configure those in a second to be the boot LUN and the CSV. And now we're bringing all of the network connections over. And then we will actually connect those together as part of defining the service. Okay. So now what we're going to do is we're going to drill down into each one of these areas. The first one is configuring the storage. In this case, we're configuring the clustered shared volume. Keep going here. Next, we're going to, okay, we just did the clustered shared volume. Assume that we have the boot LUN done already. And you can see the information about the configured element is now showing there. There was 40 gigabytes for the clustered shared volume, and 200 for the clustered shared volume and 40 for the boot. We configured the network settings, and now we're configuring the server. It's part of the batch group in this case. We have the number of servers, and remember, these are logical servers, and the architecture, as well as the memory and processor speed. We'll go ahead and configure the networks for the particular server. And we're going to assign whether it's static, DHCP, or something else. And then we're assigning the job to that particular system. Okay? We can see that the status is valid. And now we're going to go ahead and publish that to our self-service portal. So I've designed the service, and I'm going to name it, and I'm going to publish that to the self-service portal as my batch service. Okay? Now we're going to take a look from the other end. I'm logging into the self-service portal now, so I'm a line of business administrator or I'm an application owner, and I'm going to log in, and I can see that batch service, and I'm going to go ahead and deploy that batch service in the environment. So I click Enable Service. I'm going to append information onto there so it sequentially enumerates the servers within the particular service. And when I submit, now that's going to be put into the queue. It's going to start the process of provisioning that service. It's actually going to go to the administrator at this point. We can see that it's paused. It's gone to the administrator to have that approved. And the administrator, through his console or her console, will select it, approve it, and then once that service is approved, it will continue, and the person within the self-service portal can actually see the status of that. And when it's complete, all of those elements of the service will have been deployed. So in this case, all of the server volumes, all the storage volumes will have been assigned to the server. The server will be configured properly. The network connections will be all put in place, and it will have started the provisioning process for that Windows job. Okay, So as I mentioned, there were kind of two phases to this. There was the initial phase of the IT service deployment using the native Matrix capabilities. Now we're going to talk about a couple of PowerShell scripts that we've built that enable automated configuration and building of the failover cluster. And we'll show the PowerShell scripts themselves and show how they're actually instantiating the cluster within the failover cluster manager. Again, we're showing these PowerShell scripts so you can see what goes into them. They can be built into a Matrix job. We recently support the PowerShell interface as part of Blade System Matrix, so these could all be instantiated as part of a single job. So what this PowerShell script is going to do is it's going to initiate the cluster build. It's going to format the raw disks that we've made available, going to validate the cluster, create it, add all of the disks to the cluster, and bring them into the clustered shared volume. This PowerShell script can be run on any node within the cluster, and the way that you actually run it, as if you look at the top, you can see that all of the nodes are enumerated as part of the input parameters. So when you run this through Blade System Matrix, you would input those parameters, and it would automatically create that cluster. Okay? Some of the post-creation cluster activities that we'll talk about briefly. Discover the Hyper-V clusters in System Center Operations Manager, and then you can go ahead and deploy the virtual machines on top of that cluster using System Center VMM or HP Blade System Matrix, however you want to do that. Okay. And again, we talked about this a little bit before. This gives you a flavor for how the ProLiant servers will appear in a System Center Operations Manager environment. You can see all the Blade enclosures. You can see all the servers. There's actually an HP server category and an HP Blade system enclosure category that will appear in System Center Operations Manager when I install that management pack. And again, you get all of the detailed fault information and access to the ILO onboard administrator, all the resource managers within the context of that System Center environment. Okay, so let's quickly take a look at the Fabric initialization part 2 here, where we take a look at the
screen we are looking at now.
Oop.
The screen we are,
Can you turn off the volume?
the screen we are looking at now
That's
shows
not
the
supposed to be playing. Okay, so this is the PowerShell script running here. We're actually going through the process of enumerating the nodes that we want to be part of the cluster. It's starting the process of building the cluster. It's finding the unallocated disks and going ahead and formatting them. And then it's creating a CSV volume for that system, going ahead and validating the cluster, which will take a while. Again, if you were to do all these steps manually, it would probably take you quite a while. And now we're actually going in and doing the final build of the cluster. And what we'll do at the end of this process is we'll go ahead and take a look at the failover cluster manager so you can actually see that this cluster has in fact been created.
Is he just calling some of the pre-built modules PowerShell commandlets, or has HP created a custom PowerShell?
We've actually created the PowerShell commandlets that string these elements together. And we have all of the PowerShell commandlets as part of this implementation guide. You can download a toolkit along with the guide.
Separate module?
So you download the implementation guide, and then you download the toolkit, and it has all of the PowerShell scripts in there. In fact, in this presentation, we have copies of the PowerShell scripts that we've created. What were you looking for?
Whether it was just using the native Microsoft clustering commandlets, or from the clustering module of PowerShell, or whether we have HP has.
Oh, we have. Okay, yeah, we haven't created anything. Yeah, we haven't created a custom PowerShell module, but we've brought them together into a single script. Okay, so here's the failover cluster manager, showing that the scripts have in fact instantiated these items as part of the cluster. You can see the storage that we talked about earlier has been incorporated. Those cluster shared volumes are part of the cluster. And you can see the network elements in there as well. What we're doing right here is we're just making sure that all of those cluster nodes are discovered and managed within System Center Operations Manager. And as part of that discovery process, System Center Operations Manager will deploy agents out to each of those nodes within the cluster. And you can see that they've all been discovered within System Center Operations Manager. Okay?
Just one more part on the scripts that we're running there.
Yeah.
Nowhere in there are going to see any parameters being passed for, an IP address of the cluster or verification of what network was going to be used for heartbeats and so forth like that. Are we just relying on the underlying cluster wizard to make those selections?
Yeah, pretty much. And I'm not the super duper expert on that, so what we might do is take that offline and I can get to the folks who designed it for you and get that information. Okay? So the second use case that we wanted to talk about here is the flexing of IT services. So what we want to do in this case is we want to say, okay, we talked about the OLTP service and the batch service, and I want to be able to move a physical resource from one pool to another. But how do I do that without actually disrupting the services that are running within the environment? So again, we're going to, through a combination of PowerShell scripts, we're going to go through the process of putting one of the servers in maintenance mode within System Center VMM. That's going to migrate or drain the VMs from that node within the particular cluster. We're going to put System Center Operations Manager in maintenance mode, so it's not alerting when that particular server goes offline. And then what we're going to do is we're going to use Insight Dynamics to move the physical node from the OLTP cluster to the batch cluster. And then what we're going to do at that point is restart the system. It's going to assume the personality of that batch profile, that logical server profile that we talked about earlier. And then we essentially run those PowerShell scripts in reverse. So we take the system out of maintenance mode, and we take System Center VMM, that node out of maintenance mode in System Center VMM, so that any virtual machines that have been deployed will rebalance themselves using the intelligent placement algorithms that System Center VMM has for placing VMs within the cluster. Okay? So again, you could either use the GUI or the PowerShell scripts to do this. In the GUI, you would go into System Center VMM and say start maintenance mode. Same thing within SCOM. Within the PowerShell script, we can do this all as one single process. Again, a process that you could be running from within Blade System Matrix. And we have the PowerShell script. If you download these presentations afterwards, we actually have a copy of the PowerShell script that you can take a look at. Okay? Same thing for adding or removing the node from the cluster. We have a PowerShell script that automates that particular process. Again, it can be run on any particular cluster node, and it will power off that node after removal. And then what we do here is we will actually deactivate that node within HP Blade System Matrix. We'll deactivate that logical server, and then we will bring that server over into the batch pool, and we will activate it within the batch pool. Okay? So we modify that batch pool, and we move the physical server from OLTP over into batch, turn it on, and it will assume the personality of that OLTP server. And let's show that working now. So you can see the OLTP service running here. You can see all three of the servers within that OLTP service. Same for the batch service here. You can see the two nodes. And then there's the deactivated node, which we're going to assign a physical resource to later on in the demonstration. If we look at the failover cluster manager, we can see the three nodes the 3 OLTP nodes as part of that cluster, and we're going to deactivate one of those, which you'll see here in a second. And then within System Center VMM, we can see all of the nodes within the OLTP cluster and the set of virtual machines that they happen to be running. It's this final one that we're going to deactivate and move from the OLTP cluster to the batch cluster. So what we're going to do now is we're going to start up some of the PowerShell scripts so you can actually see this happening. Again, we're running the PowerShell script manually, but this could be integrated into the Matrix environment. And now what we're doing is we're actually putting the system into maintenance mode. And what you'll see here in a second is you'll see the VMs here running on this physical host beginning to initiate a live motion to other nodes within the cluster. And we'll show you what nodes they've migrated to in a second. So we're migrating this first one. When that's finished, we'll migrate the second one. And I believe they go to this Hyper-V 102 node within the cluster. Okay, the second one is going to start here. Again, it's all live moves, so no service interruption in this case. And you can see one VM moves to one node in the both nodes have moved to this 102 node within the cluster. And again, that should happen with no service interruption. What we're going to show next is we're going to show removing one of the nodes from the cluster. It's going to be this third node down here. So we will watch this occur. And it has actually gone through the process of removing that particular node from the cluster. So now you have that physical resource that is available to you. And we're going to go ahead and modify the pools within Blade System Matrix. You can see that that batch Hyper-V 103 is still deactivated within the batch service. So we actually have written a set of PowerShell scripts that will automate this deactivation process within Matrix itself. So these are scripts running in the background that do this. So we're deactivating one of the nodes in the OLTP service. You can see that that process is completed. And then we're going to activate that node in the batch service. And now it should go back home here, and you should be able to, okay, yeah, you can see in the failover cluster manager, we now have a third node within the batch pool. And now you would actually go ahead and run those PowerShell scripts in reverse to bring Ops Manager out of its maintenance mode and bring VMM out of maintenance mode, and those VMs would now be rebalanced across the cluster. So this is an example of, okay, how can you use that flexibility of cloud within your environment and actually move physical servers from one resource pool to another without service disruption. Final use case that we'll talk about here is this notion of responding proactively to an alert within the environment. So there's a failure within a blade within the environment here, a pre-failure alert of some kind. It could be a disk pre-failure. It could be a memory pre-failure. It could be a temperature issue. System Center Operations Manager forwards or captures that particular event. It is surfaced to System Center VMM as what's called a pro tip. And then when you activate the pro tip, it will move the virtual machines from the affected node within the cluster to other nodes within that cluster and automatically put that system in maintenance mode so VMs cannot be put back on it until it's fixed. And we'll show a quick example of this. What you see here is the physical node that is going to have a problem. and the virtual machine that is running on that physical node. And we can see that a failure has surfaced on that system. It's a disk failure, and it is going to surface a pro tip within System Center VMM. This is the actual virtual server, or the VM running on that server 8. And here's the pro tip that shows I have a physical device failure, and I'm going to implement it. And what we're going to show now is we're going to actually show there's a video running on this virtual machine. This is the virtual machine that's going to migrate, and we're going to go ahead and start that video on the VM as it's migrating. So we've implemented the pro tip here, and it's going through the process of migrating that VM from one server to another within the cluster, and through that entire process, the video continues to run. So we're showing the ability to automatically respond to failures in the environment with no service interruption using the live migrations. So again, video is still running as the live migration proceeds. And when that is finished, we're actually showing a deployment using OSD as part of that video, interestingly enough. We're almost to completion here. The video is still running without any kind of interruption. And now you can see that the virtual machine has been drained from server 8 and is now running on another physical node within the cluster, and there's been absolutely no impact to the end user. So using that pro technology that Microsoft has put together to automate responses to failures within the environment. Okay, so last thing I wanted to talk about in a little bit more detail is, the proof is in the pudding, right? You really want to be able to see this operating, and we have the entire hardware configuration for the Cloud Foundation for Hyper-V running this hands-on lab downstairs. And couple of things here. At MMS, we gathered all of these statistics. We were able to launch 1,600 VMs in less than 10 minutes using the configuration that was down there. And the guys actually, on 2 enclosures of blades with 2 EVA arrays, were able to run 7,200 VMs simultaneously. And they actually stopped because they got bored. They were building these and building these and building these and couldn't exhaust the capacity of the 2-blade system. So we were pretty happy with the results here. And I would encourage everyone to go down and take a look at the hands-on labs. Just a couple of statistics. The changes from MMS 2010 to 2011 by switching to this cloud platform. We went from 6 racks in 2010 to only 2 racks in 2011. We reduced the number of servers pretty dramatically here. And we also moved from a direct attached environment to a SAN environment, and significantly also saved. You can take a look at the power consumption, and then look at the network cables. We moved from 82 cables in the rack-based environment to 8 Ethernet and 4 fiber channel cables as part of this blade environment. So definitely some significant consolidation and simplification here. Pardon me? I believe actually the power figure does include the EVA. It was the total amount here that was less than what was required for the DL380 based solution. I think it's the whole amount. So in terms of the resources that you want to be taking a look at, HP Cloud Foundation for Hyper-V Use Case Implementation Guide. So we talked at about these things at a pretty high level here. You'll want to get the Use Case Implementation Guide to really dive into the details about how it's implemented. And then we also have, as we mentioned, the Cloud Foundation for Hyper-V Toolkit that has both the implementation guide and the PowerShell commandlets that we illustrated in the presentation. And just so you know, there's a web page that you can access. Hopefully this is connected to the internet. If you go www.hp.com/go/Cloud Foundation, it should take you to this page, and you can see all of these pieces here. So there's the solution brief, the data sheet, and here you can see the use case implementation guide, and also the toolkit that accompanies that. So all of these elements available for download at no additional charge. Okay, so I am free. If you guys have any questions, I think we're a little bit early, so definitely feel free to come on up. And summary, I think pretty clear here. We've done a lot of integration with Microsoft. We do have pre-sales resources that can partner with you to deliver this within your organization. And we're really excited about the level of performance that we've been able to deliver based on the results that we've seen in the hands-on lab and with the initial set of proof of concepts that we've done. So if you would also please fill out the evaluation, and I think you're entered in a drawing for an Xbox. So definitely go ahead and fill that out. If you have any questions, I'm more than happy to answer them up here. Thank you very much for your time.